So yesterday we learned about objects and classes. We started talking about object-oriented programming and we haven't finished yet. Like we are going to talk more about object-oriented programming and its different aspects. Yesterday what we did was we said that like it is another way of organizing your code or managing your software. So if you are working on big projects, object-oriented programming is supposedly a tool that is going to help you manage your code more efficiently and in a much better way. Okay, so that is one advantage of it, and there are other things that we talked about. We talked about data encapsulation. We did data encapsulation in some way when we were talking about structures. And the structures that you created in your last lab session, so there you also did something that we call data encapsulation. Now, what is data encapsulation? What we do here is like we package the data and the functions or methods that operate on that data into one full package, and that package we call an object. Okay, so the functions that reside in that object, people outside that function, by people we are referring to other functions or other code or other classes or other objects. So those objects can access those functions through an interface, just like any other object, any other real world object that we might see. So that interface is basically, so you can define that interface, which functions are we going to have and which functions would be accessible to people outside or to other programs. Okay, so if you want to make something accessible to other functions or programs, so we talked about access specifiers, so you can make it public and then people would be able to access it. If you want to restrict access to a certain function or a certain data member, then you can declare it private. So you can use the private access specifier, and that would mean that nobody outside that particular object can access that data member or function. Okay, so we talked about these as well. Right now we are going to recreate the structure that we created in our last lecture, the last lecture where we did some coding. So we are going to recreate it as an object. Okay, so you learn how to define a class and how to instantiate objects of that class. Similarly, we are also going to learn multi-file programming. Now this is something that is usually not that difficult, but it requires a lot of writing. If I want to put it into writing and it goes into the lab handout that I give you, so that will take a lot of e-state on the paper. So I hope like this video will help you in learning the steps that you will need to create your own header files. So what we are going to do is by multi-file programming, we mean that we will have multiple source files and header files in our program. When I say source file, by source file, I mean the file where you write your actual C++ code, the files with the extension .cpp. Okay, and we refer to the other files as header files. They also contain C++ code, but we refer to them as header files because they mostly contain declarations or definitions. So let's get started. So let us create a new project, and let us create a console application. You know how to do that. I won't be explaining these steps, so let us name it according to today's date, and this is section A. So this is the code that we have already. Okay, this is what we get by default when we create an application, a console application. Now we want to add, the first thing that we'll do is we will add a header file, and in that header file we will declare our class. Okay, so what we are going to do in the header file, we will only provide a sort of a declaration of the class. We'll declare what would the class name be, what data members would it have, what member functions would it have. We will not be writing code for those member functions. We'll do that in a separate file, in a separate source file. Okay, so the header file will only contain declarations. It won't contain any actual code. Now this is what you usually should do. This is how you should write code. In class we may like diverge from this technique, and why that is to save some time, okay, for no other reason. But when you have time, and I will always assume that you have time, so you should do it that way, okay. So let us create a header file. Let us add a header file to this particular project. So you can go to the file menu and you can say new file, and there you can select a header file, and then you can basically give the header file, specify the full path for it. So this is where we want our header file to be. This is the project directory, okay, and you can give it some name. So you should give it a meaningful name. For example, the C math library. So all the functions, their declarations are contained in the header file C math. So just by like listening to this word C math or reading it, you understand okay, what kind of functions would it have, okay. So you should always go for meaningful names. Right now I cannot think of a very meaningful name, so I'll just name it as our classes, okay. So when we want to include this header file into our code, we'll say #include our classes, okay. So let us name it as our classes, and let us include it in all the versions of our project. Okay, so this is what you get when you create a header file. Now this is called header file guard word, okay. So again, these are directions. These if not defined, hash if not defined, this is a directive to the preprocessor. This is a preprocessor directive. The purpose of it is, in short, to avoid including the same header file more than once. So it is possible. So if this header file is included in another header file, and that header file is included by some other header file, and you include all those three, you do not want the same thing to appear more than once, the same definition or declaration to appear more than once. So this is its purpose. So if in a given file our classes _h_ included is not defined, you define it and then end definition. Inside this define and endif, you place all your declarations, okay. So what do we want to do? We want to define a new class, okay. So previously we created a structure, and that structure was named we named it what did we name it? It was for my time, okay. So we can recreate that structure here, okay. This is just an example, a demonstration. Now you should do the same thing for if you're creating a new class, my complex or fraction, okay. So since we created that in class, so let us create it again. Now here we are going to do it by writing our own class, okay. So if you want to write a class, you use the keyword class. You say class, okay, and then you give the name, you specify the name of the class. So we are going to create my time, a new class, my time, okay. So this is going to be our class, and then again you provide those curly braces, and it ends with, the curly braces end with a semicolon, okay. So don't forget it. Sometimes you forget this thing and everything else seems to be right, and then you try to compile or run your code and it doesn't run. And when you dig out, basically you are missing this semicolon, okay. So you should be careful about these very small issues, okay. So this is within these curly braces, this is our class. Right now it does not have any data member, it does not have any member function. This is the minimal class that we can create. This is the minimal class that we can create. So for example, if we want to use this class, so we can use it. So here I can say #include our classes.h, okay? So remember this change in format. So this is the header file that we created. It is not in the standard header path directory or whatever that is. So all these header files are basically placed in an include directory. So if you install code blocks and you look at the program files that it basically creates in your system, so there you'll find there an include directory. So all these header files, IOStream and all these, they are basically there. But this one, it is not in that standard path. So here, like, it is in the same folder or directory where this source file is. So we are going to include it this way. So when I say hash include our classes.h, so all the declarations, assume that they have been copied from that file and pasted here. So like we did in our previous demonstration, we declared the structure here. So instead of doing that, we created or declared it here in a separate file, and we included that file here. It is equivalent of like this, making the same declaration here. Now we can create, this is a class, okay? This is a class. Now it is like a very useless class. It has nothing. But this is, nevertheless, this is a class. This is the bare minimum class that you can create. And the class by itself, like, it is not that useful in the sense that you cannot use it. You can only use it to create objects of this class. Once you have those objects then reside in the random access memory, and you can actually access those objects, access their member functions, modify their state and all that, okay? But right now it is not that useful. So how to make it useful? So this was my time, so let us create objects of my time. So how do you create objects of my time? You just declare variables of my time, okay? So you can say my time t1. So this is one object. Now here we are creating an object of type my time, okay? Or you can say we are instantiating an object of my time. So t1 is an object of type my time. We will refer to it as an object. t1 is an object. My time is the class, the definition or the specification or the template based upon which these objects will be created. So here we have instantiated. So if I ask you instantiate an object of this class, so you should know what you need to do. It simply means that you just need to declare a variable of that type, that class. Nothing else, okay? As many as you want, there is no limitation. You can use it and treat it just like any other variable. As there is no limitation on creating the number of integers, the only limitation is the physical limitation, the amount of RAM that you have on your system. So there is no such limitation on the number of objects that you can have. So treat them more or less the same as any other variable, but they are not exactly the same. They are a little different, okay? So this is the bare minimum class that we can have. And see, like this is, we created an object of it. We cannot do much with this object, okay? If we compile this code, and then if we like build it, sorry, okay. So you can build it and run it, and the program will run fine. No issues at all. But again, the object is useless. There is nothing inside. But you should know what is the bare minimum class that you can create. Now this is just technical information, maybe if not much use practically. Ji, what was the question? Yeah, the only thing new here is this keyword class. So these are basically preprocessor directives. So this is a header file guard word. So what its purpose is that this definition should not be included more than once in any source file. This is its purpose. So the preprocessor, it will search out, if you want to include this header file in any other file, it will basically search for this symbol or definition in that header file. If it's already there, it will not copy it or include it. If it's not, then it will include it there, okay? It is not necessary. You can do it here as well, okay? That is the easier thing to do. We could do it here. It is not difficult as well, but this is how you should do it. You should have all your declarations in a header file, implementation in a separate source file, and the main file should be separate. So you should be creating at least 3 files. You should have the main.c++, you should have a header file where you define specify your classes, and you should have a source file where you implement these classes. Now I want you to learn all this so that if you come across any similar code in your books, you should know where is it coming from, okay? And you will learn something new in the process as well. So you learned how to create a header file, you will learn how to define any member function of a class outside the class, the body of the class. So say this is the body of the class. You can define everything in here, and you can define it outside as well. So we'll see how to do that. Now let's proceed the way we proceeded there. So my time had 3 data members, okay? So let us declare 3 data members. So one data member was say int hours, the other was say int minutes, and the other one was int seconds, okay? So these are the 3 data. These were the 3 data members that we had in the structure that we created, okay? So now does it make any difference here? Okay, so it should now T1 will have 3 data members. So the size of T1 will be 12 bytes, okay? So one is that effect. The other, in the case of structures, we could say T1 dot hours, okay? T1 dot hours. Now if you look at these windows that have popped out, here you see private int hours. Can you read it? So here you see private int hours. We did not specify whether it is private or public. So if you do not specify whether something is private or public, by default the access specifier is private. So this is a point that I want to make here. So by default, the default access specification for any data member or member function is private. Default, if you do not specify it. If you want to make something public, you have to explicitly do it. Okay, you have to explicitly say this is public. Okay, by default everything is private. Now if something is private, that means I cannot access it from outside, from any other program. I can only access it from just within the class. Just within the class. From any member function of that class I can access it. Other than that I cannot access it. So let us see whether we can do that, that is true or not. So let us assign it some value, say 11, okay? Or let us say T1 dot minutes is equal to, for example, 50. Say for example. Let us try to do that and let us see if it is fine. So let us try to compile this code, and the compilation basically tells you int my time hours is private. Okay, so this variable is private and you're trying to assign its value, some value, you're trying to access it from outside my time class. So you cannot do that. You cannot access a private data member from outside my time class. Okay, so you cannot assign it any value, you cannot print it. It is no different. So if you say here something like T1 dot hours is equal to, and then you want to print T1 dot hours, okay? So this is also not allowed. So both these things are not allowed. Okay, it is a private data member, you cannot access it in any way. So again, my time hours is private, so we cannot access it. Okay, so this is how the data members should be. You can make data members public, but the principle of data hiding tells us that data members must always be kept private. Okay, instead you should have public member functions that can access those data members. So people will access the data members indirectly. They won't be able to access the data members of a class directly. They would be able to do it indirectly via a public member function. Okay, why that should be the case? So it gives you plenty of leverage. You can do plenty of things. For example, you can do data validation. So if it is a time object, So we should ensure that t1.rs should not be more than 23, okay, even if you are having a 24-hour format, something like that. So you can make this class more sophisticated. Now let me tell you like how can you make them public, and how will that fix this particular problem. So if you want to make something public, you use the keyword public, and you just say public and put a colon here. Okay? So whatever comes after public, whether it is a data member or a member function, this becomes public. Now everybody can access it. Everybody can access it. So let's see if we can do that. So let us try to compile this file and see what happens. So let us compile it. Now we won't get that error because it is public. All the data members are public now, and let us build and run. So now t1.rs is equal to some value. So how did we get this value? Yes, this is garbage value. So that principle, like that any uninitialized variable will have some garbage value, it also applies here. Like it is consistent. So a variable, any local variable, it will contain some garbage value if you do not properly initialize it. Okay. So we'll come to this initialization problem in classes perhaps next week. We'll talk about constructors. So if you are creating new objects of a class and you want to initialize data members of that of that object, so what should you do? So C++ provides you, in fact any programming language, it provides you something that is called a constructor function. So whenever an object of a class is instantiated or created, the constructor function is called, it is executed. Okay. And inside the constructor function, you can write the initialization code. So you can initialize all the data members the way you want them to be. Now you can do this. You can make data members public, but you should not. Okay? You shouldn't be doing that. Instead, you should have data members should be private. This is how you make them private. Okay. This is how you make them private. Acha. Instead, you should have public member functions through which you can access these data members. Okay. So now immediately, like, you will feel the need that we should have at least one function each to modify hours, minutes, and seconds, and another function to at least read these values or print these values. Okay. So again, remember it, like this is almost, it is basically kind of a convention, but this is you will do it so frequently that like it sort of sounds like a rule that you must follow. The data members must always be private. Okay. But you must provide functions to access, like it is not a must, but those data members that you want people to be able to change, you should provide functions to people to access those data members. Okay. Say for example, we want all these 3 data members to be indirectly accessible to other programs. So we need other programs, we need to give other programs the ability to change these data members and to access them or read these data members. Now in order to change these data members, we write functions that we call set functions. Okay, they are not some special functions, they are just functions where we use the word set, and they are meant to modify or set the value of an attribute. So for example, we can have a function void set hours. Okay. So if you want to change the value of hours, the attribute hours, so you should have a function void set hours. Okay. Now void set hours it will need to take an argument. Okay, because it has to get some value from the other program, from the main program, from other user, and it will assign that value to the hours attribute. Okay. So it needs to get an integer as an argument. Okay, int h. Similarly, we need to have another function set minutes. Okay, so this is basically a set function. Now it is not some specific type of function. It is called a set function because of its job. It basically sets the value of an attribute of a class. Okay, so that is why we call it set function. So it is not returning anything. It takes an input argument and it assigns that value to some attribute. So this would require int m, an input argument. This would require set seconds, another integer argument. Okay, so these are the set functions that we need to have. And now, like you can see, I'm not defining these functions here. This is kind of a prototype, like this is a function prototype. So I'm not defining it within the header file, inside the header file. I want to do it separately in another source file. Now it may sound or look like painful, but it is a useful exercise in some ways. Yes. Yes. Why are we here specifying explicitly them to be private? So here we use this keyword public. Okay? So now whatever comes after public, it is public. Okay? So if I get rid of this thing, so int hours, int minutes, they are also public. Okay? So one way of avoiding this thing is if you don't want to use this keyword, so if we move it here, if we put all these things here, they are private now. Okay? And now this public will affect only these functions. Okay? We don't need this thing. Okay? Again, now why did I bring these here? Now there are some conventions that people follow while writing writing code. Some people prefer to keep all the data members at the bottom of the class. Okay? And the member functions or the interface of the class at the very beginning. Okay? Some people do it the opposite way. They will bring or define the data members at the start and take the member functions at the later on. So the interface will appear later on. You can do it either way. There is no compulsion as such, but you should do it consistently. And if a certain convention is being followed in your organization for which you are working, you should follow those conventions. Okay? So either of these is fine. No problem with that. So let us keep it this way if you want it this way. Now we need to be able to read these attributes as well. Okay, so how can we read those attributes? We need to write functions which will help us read these attributes. Okay, so we call those functions as get functions. So these are set function. This is a set function. Okay, this is a set function to modify an attribute or class property. Okay, and then we can have get functions. Now if we want to read hours, so we need to have a function that would return an integer value, and we call that function as get hours. Okay? And it does not need any argument. So this is our get function. Okay? Get function to read an attribute. Now this may sound like some extra work. So if we only had those data members as public, we won't need to write this much code, but it gives you control. Okay? It is like you have to make an effort, but it gives you control over what can get out of your class and what can get in, how the values can be modified, etc. So if you want that control and we want that control, so we should do things this way. Then we can have get minutes function, and then we can have get seconds function. Okay, so these are kind of standard functions like set an attribute, set attribute, get attribute, set attribute. So if you have say 5 or 6 attributes, you need to have 5 or 6 of these functions. Okay, so I promise you, you will be writing plenty of functions in this course, and inshallah you'll see that I'll be like making good on that promise. This is our class declaration. This is how right now at this moment we want our class to be. There would be some other functions as well. Say we want to have a print function. Okay, so void print, we want to print a time object, so we can have that function as well, but this is the bare minimum that we should have. Now my point, like the purpose, we are short of time here. The purpose of this class is to basically illustrate the process, like show you how to do these things. And the rest of the things, they are not that difficult to do. So now let us define these functions. Okay. So now we need to define these functions, and we'll do that in another source file. So let us add another source file. Let us go to the file menu, create a new file, and that file would be source file. And here we will provide the implementation for all these member functions that we have. And let us save it in the same directory, and let us name it as our classes.c++. Okay. So its type would be this, so you don't need to explicitly write it as .c++. That will be automatically appended to it. And let us finish it. So here we have a new source file. Okay? And you should also be like, if you look at this left hand side, so the project window and your workspace, basically it shows you how your source files and header files are organized, so you can browse through your files here as well. If you create a source file or a header file and it does not appear here, that means it is not part of your project. And if you try to build your project, it won't be part of it. So you should, like this should flag an error. I just created my header file and it does not appear here. So what is wrong with that? So you should look, try to fix those errors. Now here in this file, our classes.c++, we will just implement the class that we just wrote. Okay? So we will define all the member functions here. Now, in order to be able to do that, you need to include the header file where we put our definition. So we need to say our classes.h. Okay? If you are using some other functions, for example, if while implementing any member function of the class, you need to use some other library, you need to include its header file as well. You need to include that header file here as well. Okay. So say for example, if you want to do some printing in the print function, so we need to have IO stream here. Okay. So you should include that here as well. And the IO stream library, like it uses the standard namespace, so you should use the keyword, you should use the full name of the function. Okay, you can do that as well, or you can say using namespace std. Okay, so we'll talk about namespaces at some other point in time, how to create your own namespaces. If we have time, we'll do that, but until then, so this is what you should have. Otherwise, cout or cin or something like that, they may not work. So they are all part of the standard namespace. Okay. Now we need to define these member functions. Okay, just these member functions. So I'm just copying this code and taking it there. Okay, and so this will basically reduce our chances of making errors in rewriting the names of the function. So sometimes that is the kind of mistakes that people make. Yes. Data members should always be private. That is like what we have been talking about. Why should they be private? I guess we talked about enough reasons about that, but for starters, say if data members are not private, anybody can change those data members in any way they please. If you do not want that to happen, then you should make them private, and you should give access to those data members indirectly through a member function where you have control. You get a value, you check that value. If it is a valid value, you assign it to that data member. If it is not, just discard it and give it some default value. Okay, so that is the purpose basically. So let me get rid of this comment here and this thing here. Okay, now here, like, we are going to define these functions. Okay, so define means we are going to write code for their bodies. Okay, so we are going to write code for each function. Okay, so I am removing these semicolons and replacing them with these pair of parentheses, and then you can get started, but not that quickly. So here, like in this file, in our classes.c++, you can have implementations of multiple classes. Okay? you can define member functions of different classes. For example, in this same file, you can put the definition of my complex class, fraction class, or any other class. You can put all those definitions here. Then your compiler needs to know which member function belongs to which class. Which member function belongs to which class. So setRs is not a standalone independent function. It is a member function of a class. So you need to specify it to the compiler that setRs is basically a member function of the class myTime. And you specify it with this operator. So myTime is the name of the class, and this is the scope resolution operator. Okay, so it resolves the scope of this setR function, like it locates where is this function defined or to which particular class does it belong. Okay, so this is kind of the full name of this class. setRs is a member function of the myTime class. Okay, and you use the scope resolution operator to do it. So there is nothing like very complex or sophisticated about it. This is something that you have to do, and it has a purpose. So we can have different member functions here. We can define different member functions that belong to different classes, and we need to specify which member function belongs to which class. We need to like resolve their scope correctly. So that is how you do it. Okay? And we need to do it for each and every member function. So again, I am copying it and I am going to paste it here and here and here. Here. Okay. So now you can write the code. Okay. Now you can write your code. So here we basically, this is the value for R's. So let us put in some checks. Say, so I'll give you an example. What is the utility of the setR function? So say for example, in our view, like R's cannot be or should not be greater than like 24. Okay? In a if myTime is supposed to store time, then the R's its value it cannot be negative. That is one thing. And it should not be greater than 24. So we can do this verification here. So we can say if h is greater than 0 and h is less than 24, say for example, G? No. We cannot have in a 24-hour clock we do not have 2400, so it resets to 00. Okay, so so these are the conditions that we need to check, say for example right now, and if that is the case, then we say R's is equal to h. If that is not the case, okay, else, then we say R's is equal to 0. Okay? So then the default value is 0. So if the user provides an incorrect value, so that is what we should do. Now here, like, this is a point for later discussion. Should this function return some value or not? So right now I'm not returning any value, but you can return some value to inform the user what happened to the input. Was it a valid input or invalid input, or did we assign it or not? Did we not assign it? So you can relay back that kind of information through some return value, but we may discuss it later on. Now I did it for the setR's function. You can do it for all the functions, but I'll keep things simple here. So because of the shortage of time, so here we say minutes is equal to m, and I'm not doing the validation. Okay, so this is data validation. This here is your data validation. So you are validating the input, whether it is a valid input or not, and you are taking steps accordingly. If it is invalid, what do you do? And if it is valid, what should you do? So you should do it in every set function, and that is the advantage of set function. And this is precisely why we do not want data members to be public. Okay. Now the get functions, they are simpler to write mostly. Like, so all you need to do is return hours. Similarly, sorry, return minutes. Get seconds will return seconds. And in the print function, you can do printing. Okay, so let us do very simple printing. I'm not doing that formatting and everything like that. I'm just printing it in the simplest possible form. So we print the hours, then we print this full column, and then we print the minutes. And then, like, print can be very complicated. It may also get some input. Do you want to print the time in 12-hour format or 24-hour format? So you can have all sorts of options here. Why do we have an argument here and why we don't have an argument here? We have an argument here because this is a set function. It is meant to change the value of the attribute, and that value should come from somewhere. So the function or program that is calling this function, it should provide that value. You should not be getting input directly from the user. In classes, you should not be getting input directly from the user, and preferably you should not be doing printing here as well. Okay, instead you should have some method to string, like you should convert whatever information you have into a string and return that string so that somebody else can print it. Okay? So you should keep your classes as independent as possible, using as few libraries as possible, especially the IOStream library. Like, you shouldn't be using these libraries in your classes. You should not be taking direct input from the user in your classes, unless your class is meant to be a class that has to engage with the user in some way. Okay, so now we have defined our class. Let us use these functions. Okay, so let us get back to the main function and let us comment out this code. Let us say initially, so we have this t1 object, so let us print t1. Let us say t1 dot print. So you have all those member functions available to you. And then let us set the values of this object. T1 dot set hours. Okay, so let us give it some, for example, some invalid value. I'm giving it 56. Then T1 dot set minutes, and minutes is, say, for example, 30. Then I say T1 dot set seconds. Okay, and you can 56. Sorry, yes, I got the name wrong. So this is set minutes. Okay, thank you. Acha, you can get these values individually. Like, you can read these values individually. You can call the t1 dot print function. Let us call the print function again, and you can get these or read these values individually. You can say cout t1 dot get hours, cout t1 dot get minutes, and cout t1 dot get seconds. Okay, so you can do all sorts of things like these. Now let us compile it. We don't have that window. Where is logs? Okay, build and run. So initially it is all garbage values. They were not properly initialized. Then we assigned them some value. Look at the value of the hours. Okay, so we assigned it 56. That is data validation. So we checked, no, it is an invalid value, and according to the rules that we have at the moment, we fixed its value and the rest of the values. Okay, so this is how you can write your class. This is how you can define all the member functions. This is how you instantiate or create objects of that class and then use it. Okay, So I hope like you have some idea of these things. G, question. Yes. So there is no limitation on how many times do you want to use a particular function. Okay. Here, like we declared, we instantiated an object, and we just wanted to see what are the values of hours, minutes, and seconds in this object when it is just created. So okay, so those are all garbage values. So this is basically the sort of the ground. If you want to change these values, if you don't want garbage to appear, if you want the object to have some predefined or preset values for these attributes when it is created, how can you do that? So we'll write constructor functions in the next, we'll learn about constructor functions in the next week. So this is basically something that should stay in your mind. Okay, this is a small problem that we may have. Garbage values are not good. You should always have initialized variables. Okay. Yes. Which get ours? No, we defined it. Here. Get ours. This is our class. This is the class that we created. Okay. Yes, we have included. Hash include our classes. That definition is available to us. Okay, here. So we can. That is why we can create this object T1 of type myTime, and that is why like here we know which functions are available to us and everything. So you can do it all in this one file, main.c++, but then it would be one huge file. So it is not good for code organization. So these are very small programs that we are writing. So if you have to write a very large program, then you will have like thousands of files, not to mention the number of functions that you might need to work on. So you need to organize your, that is why books are organized into pages of text. So you can have one big page of text, okay? And then you have to walk around on that page to find the material. So that is why you have these. So files or multi-file programming, it is useful to sort of help you organize your code. Any other questions?